For this next example, we're going to show that the left-hand equation of sine of theta over 1 minus cosine theta equals 1 plus cosine of theta over sine of theta by multiplying the numerator and the denominator by 1 plus cosine of theta, right? This is when we're multiplying by a very strategic 1. So if I have sine of theta over 1 minus cosine theta, and I multiply that by 1 plus cosine theta in the numerator and the denominator, I get sine of theta times 1 plus cosine of theta, because I don't want to FOIL things out. I don't want to distribute just yet, over the denominator, which I am going to FOIL, right? That's going to give me, because it's a product of a sum and a difference, 1 squared minus cosine squared theta. Now here you might be tempted to go ahead and FOIL this and factor this denominator back out. But if you do, then we'd get back to where we were before. So what are we going to do? Well, let's remember that sine squared theta plus cosine squared theta is 1. If I was to subtract cosine squared theta from both sides, I would have sine squared theta equals 1 minus cosine squared theta. So those two statements are equivalent. That looks really similar to what's down here. So we're going to substitute in a sine squared theta. This is like the number one Pythagorean identity we're going to use. So that gives me sine of theta times 1 plus cosine of theta over sine squared theta. Now how can I simplify this further? Well, imagine our sine of thetas were just x's. What if I had x over x squared? What would happen then? Well, then one of my x's would cancel out. So the same thing is true for our sines. So our sines are going to cancel out, and I'm left with 1 plus cosine theta over sine theta, which is what was desired. Sometimes it's also necessary to keep in mind and see where you're trying to get to. So when I got to this point, this step right here, maybe I'll change colors. When I got to this step right here, I noticed, oh, I have a 1 plus cosine in the numerator, but I don't have a sine in the denominator. How could I make this denominator have something with a sine in it? Another way to approach these problems. Next, what if I want to simplify cosine squared theta minus 1 over tan theta cosine theta plus tan theta by factoring? We're going to factor this just as we would have factored before when we weren't working with trig functions. If I had something like x squared minus 1 over xy plus x, you would know how to factor this, right? We'd factor our numerator to be the product of a sum and a difference. And then we'd take our denominator, we'd factor out the greatest common factor, which is an x, right? And then we'd simplify if we could. So let's do that here. I'm switching back to blue because I think we all can see it a little better. So if I have cosine squared theta minus 1, that's going to factor into a cosine theta plus 1 times cosine theta minus 1. And if I have tan theta cosine theta plus tan theta, the greatest common denominator down here between these two terms of this binomial, oh, technically it's not a binomial, sorry, would be tangent of theta. So I have tan of theta times cosine of theta plus 1. Well, I can then see that my cosine of theta plus 1s are going to cancel. So I am left with cosine of theta minus 1 over tan of theta. For our next example, I'm going to establish the identity. So what I'm going to do is I'm going to take what's on the left, and I'm going to get that to look like what's on the right. So if I have cosecant of theta times tangent of theta, and I want to get this to look like secant of theta, we're establishing an identity. So what are the 4 things I can do? So I can factor, I can multiply by a very strategic x, or I can rewrite in terms of sine and cosine. So think about what I should do in this case. Typically, we're only going to multiply by a very strategic one if we are factoring, if we have a rational expression. So let me go ahead and rewrite both of these actually in terms of sine and cosine. So cosecant of theta is 1 over sine theta. Tan of theta is sine of theta over cosine theta. You can see my sine of thetas are going to cancel. I get 1 over cosine theta. Well, 1 over cosine of theta's identity is secant of theta. Let's take a look at example 3. Now I've got sine squared of negative theta plus cosine squared of negative theta equals 1. This is when I'm going to have to establish this identity that my left-hand side actually equals the right-hand side. Now, normally we don't have negative thetas, so this is going to be a hint that we're going to have to use the even-odd identities. So if I have sine squared of negative theta plus cosine squared of theta, negative theta, because sine is odd, I know I can move that negative to the front, so I have negative sine of theta squared. And because cosine's even, I know that that negative really can just kind of disappear, so I've got cosine squared of theta. Well, negative sine of theta squared becomes a positive sine of theta squared. And I know by the Pythagorean identity that this equals 1.